Hello there, my name is Alex Rose. This is Challenge 3, we're the Data Doctors. This is our team. So this is the project that we're working on, as you can see, dealing with commodities and looking at how we can create a system that improves the accuracy of assigning codes and drastically reduce the time taken. Next slide, please. These are some of our identified pain points dealing with issues relating to efficiency, the size of the data set, which was nearly 152,000 lines of code, and the inability of the data analyst to be able to efficiently and accurately check the existing data library. So these are some of our considered solution. The challenge provided us of anonymized data, which we looked into. Using a formula, we identified the 8-digit code that we then used. We also cleaned the data, and looking through columns G and T, we removed all anomalous data in order to better improve our data. Continuation of that, we then produced a temporary basic pivot table to search and filter through the different variables required. Looking through this, that had 2 drop-down filters and 2 pop-ups, which were used as well to identify the associated class name and select the correct choice for the commodity. This finally outputted the associated code in relation to this.
So using the cleansed data, we're able to now look at, identifying UNSPSC code already available. And then with that, we created a macron using VBA to be able to just quickly check. And if it's available, it shows us where it is available based on the cleansed data, and where it's not available, it creates a new row.
So there was a database on the website. However, it was and it was in Excel, but it was behind a paywall. There was a free PDF that was available, but then we needed to write a script in Python that would scrape the PDF and convert it to a CSV. A further Python script was also constructed, which just separated the CSV fields into name, description, and ID. All of the IDs followed an 8-digit structure, wherein the first 2 digits relate to something called segment, 3rd and 4th to the family, 5th and 6th to the class. The final 2 digits just being an index to force it to be unique. Using our list of codes that we generated from the PDF, we made a reference table that included the full hierarchy of every single item. This would be crucial for submitting requests for new codes later. Next slide, please. So we wrote a function in Excel that would just allow a user to filter the reference table for any keywords of the user's choosing. This would determine if the item that they're looking for already exists. Next slide, yeah.
And instead of searching keywords, what we can do is we can actually extract the information and meaning inside the description or the name and give suggestions according to that. For this purpose, we use large language model called BERT and use it as an information extractor and build a machine learning model. And we wrapped that with a widget, as can be seen in the images. It gives 10 most likely suggestions to the input. In this case, it's coffee. Next slide, please.
So if the machine learning widget and both the manual data search don't find anything, then the code probably just doesn't exist. The user has to add it to the table, and this is where the hierarchy comes in. The user fills out 3 dynamically evolving drop-down boxes to best describe their items. So they fill in the first one, say live animals and live animals and plants, and then that will restrict what they can choose in the second one. So they pick live animals, and in the third one they can pick livestock. And each one of those drop-down boxes relates to 2 of those digits in the ID. Next slide, please. So as I said, this constructs the first 6 digits of the ID, and then we just choose the last 2 digits to force it to be unique. The user can then add a name for their commodity. If that name already exists in the table, then it's rejected, and they can also add a description. The add to registry button just executes a bit of VBA code that will then add their item to the reference table, and that will update the table permanently. You can see we've added reindeer. Next slide, please. So for the first of the questions, how does your solution reduce the amount of time that it takes to assign a code for a good or service? Well, we made it a lot easier for the user to determine whether their item is in the data set in the first place. So that's either through the manual filtering that we built in Excel, or through the machine learning where you can use a description or a name of an item to determine if something similar exists in the table. If it doesn't exist, then we've made it very simple for a user to add the item to the reference table by filling out the drop-down boxes. Next slide, please.
Question 2 relates to how would you change the way information is submitted as part of a code request? Does a clearer way need to be defined? The initial approaches lacked process control. This led to numerous errors and empty cells, impacting the ability of staff to feedback new topics. In essence, this affected the accuracy and efficiency of the process. So the filter function allowed, though, for an immediate location of specific codes, and these compulsory fields made the accuracy far improved. Next slide, please.
And finally, what will we do differently if we have more time? Well, the first thing is we make a dedicated user interface that would combine both the machine learning widget and the Excel wizard component. Ideally in Power Apps was what we were thinking. And then also if we could have the request for the new item to be sent via email to an administrator or something, so the user doesn't have total control. We'd also improve the separation algorithm we used for the CSV and the PDF. There are some errors on the database. Ideally, we wouldn't have to use this because we would have the Excel database that is hidden behind a paywall. Finally, Mehmet?
Finally, we would train a neural network for this link descriptions to the code. Right now, we are using a nearest neighbor algorithm, although it doesn't give the best results. Thank you.
So that's everything. Thank you for listening.